In Chapter 6, getting practical, getting outside of just right triangles, hence law of sines in this section, law of cosines, the next section. Getting more practical, getting outside of just right triangles. Getting into physics a little bit with vectors. With vectors. But to that end, quick reminder, you're going to need your calculator, so bring it to class for all of Chapter 6. You're going to want it for the test, you're going to want it for any quizzes, you're going to want it for homework to get final answers. You're going to be getting decimals all over the place. And my hint, once again, is to pretty much be in degree mode, so I would go ahead and go do that now. But let's picture, what's some way that you could describe that figure to me? Go. Oh, sorry, the top one. The one in the big highlighted box. Give me something about it, Adam. Acute? Why is he saying acute? Based on the picture. All three of the angles are less than 90 degrees. Good. It is an acute triangle. What else? It's a triangle. A squared plus b squared is c squared. Why is that not true? It's not a right triangle. So it is an acute triangle. As a definition, it's not a right triangle, which means Pythagorean does not apply. Do we know anything about how A and B and C are related? How about lowercase a and b and c? Do we have anything with how these are related? Okay, little a is across from big A, little b is across from big B, right? So we do have opposite sides with their corresponding angles, that's true. But we have no formula that relates the sides without including some sort of angle. But what do we know? There's one fact that no one pulled out. Besides the fact it is an acute triangle, Pythagorean does not apply. It's not a right triangle. But what is one fact we do know? Something plus something does equal an actual number. What all? Good. Angle A plus angle B plus angle C is equal to 180. So we do know that one. But as far as the sides, we have nothing until we look at the law of sines. Law of sines says, given any triangle, not just a right triangle, any triangle, the ratio of a side with its corresponding sine of angle, a side with sine of its corresponding angle, the ratios will all be equivalent or will all be the same. Now, why is there an or? Do you guys think it's true, knowing what you know about algebra, about equations, about how to manipulate equations, do you think it's possible? Could we do 1 over to every single piece of this equation and it still be equivalent? So why am I saying 1 over? What does 1 over do? First of all, what's the word for 1 over? Reciprocal. And if we reciprocate, can we do that in math? If we take the reciprocal of every single expression, what's going to happen? So aren't they the exact? We could multiply by sine of A, and then we could divide by A, and then we could multiply by sine of B and divide by B. We could actually make this equation into that equation. So what's the big deal? Well, let's see if we can figure out from examples today why sometimes this might be easier and why sometimes that might be easier. But here's the long story short. Have you guys ever in your math career been given the directions of solve this triangle? What are they asking for if they ever ask you for solve this triangle? All the angles and all the sides. Back to geometry, right? Now, will they have to have given you something? Yes. In a right triangle, they don't have to give you very much. In a non-right triangle, they have to give you a little bit more. Let's see how to play with it. At the very, very bottom is a note saying like, hey, P.S., this is really, really useful for these. But let's just go do some examples and see if we can figure that out for ourselves. So, what if, oh, sorry, it's on the ceiling, isn't it? There you go. AAS, you guys remember angle, angle, side? Angle, side, angle? Angle, side, side? That was the bad one. Side, side, side? Angle, angle, angle? That one was bad too. But we're not talking about congruence right now. If you guys remember geometry at all, you might realize that some of these proved congruence, CPCTC, ooh. No ding ding dings for geometry. The light bulbs are turned off for today. Anyway, you saw these in geometry, but we're not proving anything. We're not talking about whether or not a triangle is congruent or not. We're just saying, hey, if they give you these pieces of information, what can you do with them? But I think most of you are just going to look at the triangle and say, hey, I have a formula. Let's plug and chug and see what happens. But when you're looking at law of sines, oops, wrong way. I know there are 3 equivalent statements, but you're not going to be using all 3. We're going to need to set up an equation with just one equals, whether taking these 2 or those 2 or these 2. We're not going to be making one huge equation with 3 different parts. We're going to be narrowing this down to what we've been given. For instance, oh my goodness, my orientation's a little bit off in this one. What part of that law of sines do you think we're actually going to be using? B and C? How come, Kyle? We're not given A at all. Okay. So with Johann's like, hey, solve for all the sides and all the angles, and with the one fact that we know about any triangle, we could do what Kyle is saying, which is solve for angle A, but it's not specifically been given to us, right? So even though we're going to do that eventually, technically to begin with, maybe we should just think about C and sine of C and B and sine of B. Doesn't mean you have to necessarily write that equation, but that's technically where we're starting from. What can we plug into this, cool kids? What do we know? We don't know sine, but we do know angle C, which is 105, right? To find sine of 105, unit circle. Oh, no. That's 90 and 15. That's not a 30, 45, or 60. Do you see why you have to have your calculators out? That's not unit circle. B, we know, is 20. And sine of B, sine of 45. Okay, we could do that one with the unit circle, in the unit circle. But isn't this a good thing if we only have one unknown? Can't we just solve for C pretty quick and easy by multiplying by sine of 105? Do we have to rewrite it to make it pretty to put it in our calculator? Heck no, techno. Go plug and chug. You guys don't need to see me do this. I'm just going to do it over here off to the side to make sure you do it right. You in degree mode? (20 sine of 105) all over sine of 45. Double check me. Is it looking good? 27.321? Yeah, it says 2 decimals. I always go 3. But there you go. But Johann said solve for everything. We didn't know C, now we do. We don't know angle A, but that one's easy, right? Angle A, anybody already figured that one out? Yeah, because we have 105 plus 45 is 140, 150. And what do all angles of a triangle add up to be? So that one must be 30 degrees. Okay. But what's the last thing we're missing? Side A. So I'm going to go ahead and say, hey, all right, so A over sine of A, sine of 30 degrees. If this was a decimal, I would try to include as many decimal places as possible to avoid error, but it's a perfect answer, so I'll just plug it in. What do you guys think? Should I compare it to B or C, and which one? They're both technically correct, but one has a danger the other one doesn't even have to worry about. Why do I agree with Kyle and I say that B is probably the best one to use? It is acute. but I don't think that makes a big difference as far as plugging in. Why, Kyle? Right. If we were to go using C, do you remember that we rounded? And we rounded a little bit of error. And so we would need to include the whole nasty decimal, which you could do. You could go scroll up in your calculator and use the whole nasty. But why not just use the pretty number instead? That would be my advice too, to avoid error, to use nice pretty numbers, nice even numbers as long as possible. So then A is going to equal, can you guys go ahead and plug and chug this for me? If you got the last answer to match, unless you plug and chug something incorrectly, we should be good to go. And as long as someone else matches up with you, we're okay. Austin, what'd you get? Oh, he's still going. And then Gavin's going. Jaden, what you got? Sweet. Is our triangle solved? Because we had pieces of information, we found the missing 3, and we're done, 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 done. Why am I calling this AAS? Because what were we given? Angle, angle, side, or side, angle, angle, either way. But is this something to memorize? No. It's just to realize, hey, if you have more than one angle and a side, law of sines isn't too bad. Shouldn't be too bad. Oh, I did the wrong button again. Struggle. Okay, ready, set, go. There's no picture. That's okay. Use law of sines to find what's missing. And hopefully you guys realize what's missing. Pretty quickly, pretty easily. Hi, frozen computer. How are you? Take a second on your own. Given the formula that we've been playing with. And I think it's a good idea to start with A's and C's. Does that make sense? Start with A's and C's. Why am I writing second app off to the side? For the minutes, remember there's that nifty angle menu. Just a few of you might be like, ugh, there's no picture. I want there to be a picture. You could draw a picture and label an A and a C and a C. But maybe some of you realize if you know the formula, you kind of just need to plug and chug the A, the angle A where it needs to go, the side A, well, as an unknown. Angle C. So you could draw a triangle and label stuff. Or you can just plug and chug. Okay. Well, it's going to be a decimal anyway, so it's okay. Because they gave us a decimal here, so they're not necessarily forcing us to go to minutes. But you could always use our nifty conversion button in second apps, the DMS button, if you wanted to make it pretty. If they make it match with the back of the book. But I wouldn't force it either way. Before you move on and keep on going, everyone knows how to use that second apps button going to the proper place. Especially if someone doesn't have a calculator today, help them out, make sure they're okay. Because they're going to need to be plugging and chugging stuff in homework, yeah? Am I good? No? I'm in degree mode. 8320. Oh, 18.1. Lo siento. 22.055. Anybody else get 42.067 for our missing angle? Okay, double check real quick, everyone in your group. Do they need any help with plugging in? Are their answers matching? What's the last piece we're missing? We're missing, we have capital A, little a, have capital C, little c. We have capital B, we're missing little b. I'm not going to show you my work. You guys figure it out if you haven't yet already. How'd you guys set up the expression for little b? Good. Replace little a with little b instead, but instead of using angle A, you have to use angle B. But what number do you think I used for angle B? Did I use 42.067? Nope. What did I use? 6666666, right? You don't have to necessarily go copy the entire thing up above, but don't round it if you're going to be using it. Round it for your final answer for that angle, but don't round it for the rest. So double checking the expression. And y did 0.06666 instead of 0.067. Then hopefully you guys get that I would multiply this guy to the other side. 18.1 times that denominator, sine of 42.06666. All over sine of 54.6. And what do you guys got? You guys agree with Adam? Yeah. Now guys, I'm not putting any units because they didn't give me no centimeters, feet, inches, miles, I don't know. But if it's a word problem, they start putting units, we know how to label our answers, right? Cool. If I stopped right here, what would you think about section 6.1? Easy cheesy. So I wonder if it ever gets hard. Now, do you have to know your formula? Yes. But how could this get hard? I know the screen's being a little bit weird. Let me see if I can get it to not be a little bit weird. Now hold on, does this look weird? Okay, with the extra wording up above, go ahead and write the wording and leave blanks. I know you were going to write the phrase painful case, but pause. If you were just given this information, wouldn't you start plugging it in? Okay, I want you to start plugging in, just see what happens. It's 3 pieces of information, just like you had in the other 2 problems. You don't have a picture per se. All I did is give you an angle of 20 with no lengths. I mean, I didn't really give you much. But get down your 3 pieces of information. Angle A is 20 degrees. Side B is 5, and side A is 3. So far we've done 2 examples where we were given 2 angles and 1 side and we plugged in and we solved. Well, whatever, we're given 1 angle and 2 sides. How bad can it be? Well, ready, set, and go. Angle A is 20 degrees. Side B is 5. Side A is 3. Plug it in. Solve for the unknown. Plugging in isn't so much the hard part. It's the extra hidden case that gets weird. The plugging in shouldn't really be too bad. Just something is going to change just a little bit. But what? Whoa, whoa, whoa. Why did I write the formula the other way? Any ideas? What's my unknown? The angle. So what am I going to put on top? The part with the angle. It's just a simpler way of doing it. Some of you might have rewritten it the other way and then you're like, oh, I have to get to the variable which is in a denominator. It's just a little bit easier if you write whoever's unknown in the top. But did you guys get how we had to use A's and B's and angle B was the missing one? So then now when we solve, it's not a big deal. We move everything to one side, but what's the problem over here? What do I need to solve for? I need to solve for angle B, but what do I have? Sine of, well, how am I supposed to get angle B if I have sine of B? Come on. Inverse, good. Oh, no stress. Okay, cool. So, sine inverse, second sine, that's a thing, right? Of 5 sine of 20. Make sure you don't end your for the whole thing until you type the divided by 3 in. Anybody else get 34.753? Wait, no. Our calculator gave us 34.753. We're done, right? What does ambiguous mean? There are multiple options. Ambiguous. So that's the only answer? Maybe. Real quick reminder, sine inverse. If I was to give you something like sine inverse, oh dear, that's a bad marker, of 1/2. If I was to give you something like sine inverse of 1/2, isn't this a unit circle value, guys? 1, 2, 3. Doesn't this happen at 30 degrees? Okay. Is 30 degrees a proper answer? Yes. But here's the struggle. What if I didn't give you sine inverse? What if I gave you sine of angle B is equal to 1/2? Couldn't we also answer with 150 degrees? Why? Because sine is positive in the first quadrant, but where else is sine positive? Second quadrant, all students. Why is this a problem? Isn't that what we have? Sine of angle B is equal to a number. Later give us one answer. Why do we need to consider the other answer? Wait a minute, all angles in a triangle add up to be 180. Uh-oh. Couldn't 150 also be in a triangle? 30 could be, but 150 could be also. So there's the ambiguity. Now hold on, let's check out this example. If 34.753 is one angle, how could I find the other angle? I mean, this one was unit circle we memorized. Subtract from what? 180? Because it's, oh yeah, because it's up from 0 and then it's back from 180. So guys, what's 180 minus? This is where the ambiguity comes in. We have to check the 180. It's the sine inverse. Whenever we have to do a sine inverse with law of sines, we have to check the 180 minus. So what's 180 minus our 34.75 blah, 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 blah? Did you guys get 145.247? Why am I going to say yes, there are two options? The only thing that limits me, because remember, it could be 0, could be 1, could be 2. 0 would come from an error in your calculator. If you did sine inverse error, well, it's not a possible triangle. I'm done. That's 0. 1 says I plug in and I try 180 minus, and the third angle wouldn't work. But check it. Can 20 degrees and 145 still leave room for a third angle? Yeah, I still have room for a third angle. That's a possible triangle. But can 20 and 34 also give me room for another triangle? Yes, so here's the dealio. Whenever in law of sines you are given one angle and two sides, you have to check case 1 and case 2. And if there are two possible answers, guess what you're going to have to do? Find a little c and an angle c for the one case, and find a little c and an angle c for the other case. Because which one's true? I have no idea unless they give me more information. I have to give both as answers. Cool, kids. Rock out on homework. See how you do. Plug it into law of sines. Sometimes it's basic. Sometimes it's ambiguous. Check case 1, case 2. We'll come back tomorrow and recap and see how it went. Sound good? Bye, guys.
How are we supposed to check the cases if we don't know the other angles?
As long as it's possible, we just have to say it's a possible answer. Like, there's no way of narrowing down to just one of them unless they give us more. So we say, hey, they're both possible. There you go. Done. Does that make sense?
Well, like, we don't have any other C. We only have one.
Right, but once we have angle B and A, we find the appropriate C for that case and then the appropriate C for that case. So there'll be two answers sometimes instead of just one. But, bye, kid. But if I had something instead, like the sides were different, and this was like 15, and this was like 165, that's not possible. So, we forget them.
Turn into Google Docs, right?
Yeah. Oh, I didn't give my shortcut. We'll talk about it tomorrow.